All right, let's look at the integration scale called integration by parts. Among all the integration scales, this is probably my favorite. So let's look at this example over here. We just want to integrate this function over here. If you look at it, the integrand usually consists of two parts. It's a product, okay? And also, if you look at the name of this integration scale, it's called integration by parts. So what it means is that we're going to integrate part of the integrand first. And the whole purpose, of course, is to make this integral into a simpler integral. So you don't need to really worry about which part to choose to integrate first, because you will learn this very fast. Because if you don't choose the part correctly, you are going to get a new integral that's even harder to integrate. And then, of course, after some experience, you will know exactly which one to integrate first. So indeed, we have a rule. If you have a polynomial multiplied by either sine or cosine or e to a certain power, then you integrate sine or cosine first. We will see why. Okay, so now we integrate this sine x plus a, this part dx first. And this is what we have. So we have negative cosine x plus a plus c. You don't really need this c when you put it inside. So once it's integrated, we put it behind d. So this is, in fact, this is what we do. Integrate means put it behind d, negative cosine x plus a. You may say, is that really correct? Of course it is. If you look at what's d cosine x plus a, that's differential, right? And so you take the derivative of cosine, sine, and negative, and you have sine x plus a and dx. Of course, you recover what you have. So remember, dx now also is important. So now once you finished this part, and then you have one function in the front, you have, you see over here, this is the function in front of d. And you also have another function behind d. So now the formula for the integration by parts means multiply them together. So it's x times negative cosine x plus a, and then subtract swapping them, and then you have negative cosine x plus a and dx. Look, now this is easy, right? This is easy. That means we are doing it correctly. This is exactly what we learned in Calculus 2 when we did integration by parts. At that time, we were saying that u dv is equal to u times v minus v du. And that's the formula for integration by parts. So once we have this step over here, then we have negative x cosine x plus a, and then plus integral cosine x plus a dx. And one more step, then we have the answer. So this is equal to negative x cosine x plus a and plus sine x plus a. This is an indefinite integral, so you add c at the very end. All right, that's it.